Good morning, dear students. My name is Ferhan Mazher, and today is 13th of March 2021. The subject we are studying is Physics 5054. It's O levels physics, and we are working on today. We are working in this session. We'll be working on the an MCQ paper. This is 2021 to October November 2021 to paper. So in this session, we are working on a MCQ paper. So let's start. The paper is showing on your screen. Let's start this paper. The first question. A heavy nail is fixed firmly to a wall. It is pulled by a string at 40 degrees to the vertical. The nail does not move. Three forces act on the nail: its weight, the tension in the string, the force exerted by the wall. Okay, so basically what is happening, there are three forces, and those three forces, their sum should be zero because they have balanced each other. The three forces, which is the tension in the string will be acting in this direction. The weight of the thing nail will be acting downward, and wherever the third force, which will be force exerted by the wall, the sum of these three forces, the tension in the string, the weight, and the force are exerted by the wall, their resultant should be zero. Okay, so he says three forces act on the nail: its weight W, which will be acting downward, the tension T in the string, which is making 640-degree angle with the horizontal, and the force R exerted by the wall. Okay, which diagram, let me reduce the size. He says, which diagram drawn to scale represents the three forces? The first question is very tricky. So I told you one fact, because the three forces acting on the nail, and they have balanced each other, so their resultant should be zero. So I am looking for the correct diagram will be that diagram which will be obeying the head and tail rule, and the resultant should be zero. So head and tail rule says that the three forces which you want to add, for example, here we have three forces and we want to add them. You will take the first vector. On the head of the first vector, you will put the tail of the second vector, and then on the head of the second vector, you will put the tail of the third vector. Here, because the resultant is zero, so that they should make a closed figure, and the head of the last vector should be on the tail of the first vector, because the resultant needs to be zero. If you leave diagram A, look at the diagram B. Here the tension is shown, and here the weight is shown, and their tails have been joined. If you join the tails, then we need to use the parallelogram law, and so this diagram B, that's not obeying the your head to tail rule. So basically, you see, the T and the R, they might be in the right direction, but this third is not making any sense. Okay, this is not actually obeying the head to tail rule. In the head to tail rule, the first vector, on the head of the first vector, you put the tail of the second vector, and on the head of the second vector, you put the tail of the third vector. And because the resultant is zero, the head of the third vector should be joining with the tail of the first vector. So the B cannot be the answer because it's not obeying the head to tail rule. So look at the C diagram. In the C diagram, we have the same problem. You see this tension, weight, and this R is direction is not right. Here again, the tension and the weight and the R direction, that's not right. So B, C, D, they cannot be the answers. If you look at the diagram A, if you look at the diagram A, you see by this vector he represented tension. Okay, that's the right direction. And where the head of the first vector, then he put the weight, the second vector. The tail of the second vector is at the head of the first vector. Oh, that's good. So, and then the third vector, the tail of the third vector is at the head of the second vector. And the head of the third vector has joined the tail of the first vector. This diagram is actually obeying the head to tail rule, and this diagram, because the head of the last vector is joining with the tail of the first vector, which means that the resultant force will be zero. It means that the three forces have balanced each other. So I think A is the right choice. So I think the A is the right choice. I have the marking scheme also, so I will check the answer. Okay, so question number 1, A is the right answer. So hopefully you have understood this. It's a little tricky question. Head to tail rule is used, and in the head to tail rule, I can explain you again that in the head to tail rule, when you try to add three vectors and you want the resultant to be zero, that is the important thing is we put the first vector on the head of the first vector, we put the tail of the second vector, and on the head of the second vector, we put the tail of the third vector. And because the resultant needs to be zero here, so for the resultant to be zero, the head of the last vector should be joining with the tail of the first vector. In this way, we represent by the head and tail rule the zero resultant of the three forces. So A is the best option. So for question number 1, A is the right option. Okay, on your screen, we have question number 2. A car begins to move, it speeds up until it reaches at a constant speed. A car begins to move. Begins to move means that it was at rest and then it has started moving. It speeds up. So its speed is, its velocity is changing. And ultimately what happens, its velocity or its speed becomes constant. It continues to travel at this constant speed for the rest of the journey. You see, when the speed was zero, then it was gaining speed, and then the speed became constant. It means there is change in the velocity. When there is a change in the velocity, we say we have acceleration. And when the speed becomes constant, you know that the speed becomes constant, and then the car continues to travel with that speed. It means that the acceleration has become zero. So the car speed is changing. It was zero, then it increased, then it became constant. It means the speed of the car is changing, the velocity of the car is changing. And another important thing, if you look at the acceleration, what happened with the acceleration? At the start, the car begins from zero speed, and then its speed increased, so it has certain acceleration. And eventually, the speed became constant. When the speed will become constant and the car continues to travel with that speed, constant speed, the acceleration will become zero. At constant speed, the acceleration is zero. So it means the amount of acceleration has also varied. There was some acceleration, and then there was zero acceleration. So both the velocity and the acceleration, they both have changed. What happens to the acceleration and what happens to the velocity of the car during the journey? A option is both the acceleration and the velocity change. That is the right option. Only the acceleration changes, that's wrong, because the speed also changed. Only the velocity changes, that's wrong. The acceleration also changed, because at the start, when there was a change in the speed, there was acceleration. But when the speed became constant, the acceleration became zero. So there was a change in the acceleration also. So C cannot be the option, neither the acceleration nor the velocity changes. That's wrong. So I'll think that for question number 2, the A is the best option. Question number 2, A is the best option. You can see question number 2, A is the option. Okay. So let's move to the next question. Question number 3 is on your screen. The speed time graph for a car's journey is shown. During which part of the journey is the car moving with non-uniform acceleration? It's a speed time graph. And you know that speed time graph, the slope or the gradient of the speed time graph represents the acceleration. So when the body is moving with the uniform acceleration, the speed time graph will be an inclined line. When the body is moving with the zero acceleration, the speed time graph will be a horizontal line. And if the acceleration is non-uniform, then the speed time graph will be a curve. So he is asking us to look into that portion where the acceleration is non-uniform. On the speed time graph, the non-uniform is represented with a curve. So look where we have curve. So here at the C portion, the speed time graph is a curve, which means here the acceleration will be non-uniform. For question number 3, I think C is the right option. Let's check our marking scheme. Question number 3, C is the right option. Next question on your screen, question number 4. We are attempting October, November 2021 2 paper. It's an MCQ paper. Question number 4. A car is traveling forward at high speed. The brakes are applied and the car skids along the road surface. In which direction and where does the friction force act? It's a very, very tricky question. I have drawn, let me show you. So, okay. So hopefully you are able to see. Here, in the first diagram, I have shown here 2 diagrams, and I want to increase the size. I don't know. Okay, so in the first diagram, you can see here I have shown a car. If you have applied the brakes, stop rotating. So now the brakes are applied, but the tires are because you have applied the brakes, the tire will become jammed and they will not rotate. So this will be the situation. This first one will be the situation, this diagram. So now the car is supposed moving in this direction. You have applied the brakes. The tires are no more rotating. So they will skid on the road. So the whole car is moving in this way. But the important thing is that these tires are not rotating. So when they will rotate, they will be skidding in forward direction. The friction between the tire and the road will be opposite to the motion. That will be in the backward direction. So the direction of the direction of the friction, if the tires are not rotating, will be in the backward direction. So backwards on the tires, and A is the right option. For me, question number 4, A looks the right option. Okay, now try to understand a very important point. Try to understand this point. Try to understand this point. Here, this diagram here, we have shown you an example where the tires are not rotating, the brakes have been applied, but the car is still skidding along the road. So the friction will be in the backward direction opposite to the motion of the car. This is another thing which is not asked here, but to explain you, I have just made this diagram. For example, when the brakes are not applied, so the tires will be rotating. You see, if the car is going towards right, the tires will be rotating in the backward direction. So when the tires are rotating, it's very important to understand that if the tires are rotating, the brakes are not applied. If the tires are rotating, the tires will be rotating in the backward, in the clockwise direction, and the friction between the tire and the road will be in the forward direction. It's a very important point that friction will be in the forward direction. If the brakes are not applied, tires are rotating, the car is going towards the right, the tires will be moving, rotating in the anti-clockwise the clockwise manner. Sorry, the friction between the tire and the road will be in the forward direction. This MCQ comes in some papers. I hope you are able to understand. But the question right now, the question which is in this paper, is asking about this first situation. He's not asking the question on this second situation. But in some paper, you will find this situation. I hope that you have understood this. Okay. The next question, question number 5, that is on your screen. Question number 5 is on your screen. A car of mass 800 kg has a forward acceleration of 2.5 meter per second square. A frictional force of 1200 Newton opposes the motion of the car. What is the driving force due to the engine of the car? You see, we know the acceleration, we know the mass of the car, so I can find that force which is producing this acceleration. According to Newton's second law of motion, F is equals to ma. F is equals to ma, according to Newton's second law of motion. So if I know the mass, I know the acceleration, I can find out that force which is producing this acceleration. So if F is equals to ma, so F is equals to 800 into 2.5 meter per second square. So when you multiply them, let me show you, I have done this working also. Okay, so here we go. Let me show you. Okay, so F is equals to ma, so 800 multiply 2.5, so it will give you 2000 Newton. So the force which is producing acceleration, that is 2000 Newton. The question is, what is the driving force? You see, there is frictional force, and that is 1200 Newton. So the driving force needs to provide two forces. It needs to provide the force to overcome the friction, plus it needs to give the force to accelerate the car. So the driving force must be equals to the resultant force plus the frictional force. So the resultant force which provides the acceleration, that was 2000 Newton, and the frictional force which the driving force will have to overcome, that is 1200 Newton. So if you add them, the answer will be 3200 Newton. 3200 Newton. So our answer will be 3200 Newton. Let's check what is the option. 3200 Newton. This is D option. Question number 5, D is the right option. Let me check from the marking scheme. Yeah, the D is the right option. Okay, the question number 6 is on your screen. A satellite orbits a planet in a circular path as shown. It has constant speed. There is a force on the planet due to the satellite. In which direction is the force on the planet? The force which is on the planet, you see the force between the satellite and the planet, both the forces, the force is gravitational force of attraction between the planet and the satellite. The satellite will be attracting the planet, and the planet will be attracting the satellite. This is because whenever you have, this is the law of gravitation. This is the gravitational law, Newton's gravitational law. It says that the two bodies who have mass, they always attract each other. They attract each other. They have a force of gravity between them. So the satellite will be attracting the planet, and the planet will be attracting the satellite. The question is, there is a force on the planet due to the satellite. So due to the satellite will be attracting the planet to itself. The satellite will be attracting the planet to itself. So B looks the good option to me. B looks the right option, sir. Let us check. B. You see, in this question, there is a problem that all my students, normally they are obsessed with the centripetal force. They are preoccupied with the notion of the centripetal force. So remember the wording he used. He said that there is a force on the planet due to the satellite. The satellite and the planet, they have gravitational attraction with each other. the satellite will be attracting the planet and the planet will be attracting the satellite. He said the satellite, the force which is acting on the planet due to the satellite. So that will be a gravitational attraction and that will be toward the satellite. It's a tricky question. Okay, so here we have, let me reduce the size. He says a block is hung on a spring balance. The marker inside the balance is pulled down by the block. What can the position of the marker be used to determine? You see, these spring balances, they are basically used to find out the weight, and when you measure the weight, the unit should be Newton. They are also calibrated and then they are used to measure the mass. When you use them to measure the mass, then the unit should be kg. They can be used to measure the weight, then the unit will be Newton. They can be used to measure the mass, then the unit will be kg. What can the position of the marker be used to determine? A option is the mass of the block in kg. That can be the right answer. The mass of the block in Newton. Mass is not measured in Newton. The moment caused by the block in Newton, this is not used to find out the moment. It do not measure the moment directly. The weight of the block in kg, the unit is wrong. Weight is not measured in kg. So it looks that A is the right option. A looks the right option. Let's check the marking scheme. Okay, question number 7. A is the right answer. I hope you have understood. Next question. This is question number 8. Okay, question number 8 is showing there is an astronaut on a planet which has a gravitational field strength 1/5 of the value on the Earth. The G value on that planet is 1/5 of the value on the Earth. The G value on the Earth is 10 Newton per kg. The G value on the Earth is 10 Newton per kg, but on that planet, the G value is 1/5 of the value of the G on the Earth. So the G value on that planet will be 1/5 multiplied 10. That will be 2 Newton per kg. He hangs samples of rock from a spring balance designed for use on Earth. The spring balance is designed or calibrated for the Earth. Each sample has a mass of 0.1 kg. The spring balance reads 1.0 kg on that planet. How many samples of rocks are there? One thing is very important. You see, when you use the spring balance, basically when you hang some object with a spring balance, the spring balance has some extension in it. So whatever the force or the load is needed to expand it, the same force or same load or same weight will be required to expand it on the other planet. Whatever the load or whatever the force is required to expand the spring balance to a certain value, to certain length, the same weight or same force or same load will be required to expand it or on that planet also. So let us find out that if the spring which was calibrated for Earth, it was supposed to be used on the Earth, if it shows 1 kg, so if it was on the Earth to show an extension of 1 kg, how much force is required? I have done this and let me show you. And okay, so on your screen, I hope you can see this, and I want it to be. Okay. No. Here we have the slideshow. Okay, so question number 8 is showing on the screen. Extension, depends upon the load, how much force you have applied. So if you want to create a certain length, whatever is the force required on the Earth, the same force will be required on the planet, on the other planet, to create the same extension in the same spring. So on the earth, suppose if it was calibrated for the earth, for example, on the earth, the mass was 1 kg, the G value was 10. So how much load or how much weight was required on the earth to create an extension which can show you 1 kg? So W is equals to mg 1 multiplied 10 and it will be 10 Newton. So it means the force which is required to create that much extension in the spring balance, that load or that weight is 10 Newton. On when you take it to the other planet, the same weight or same force is required, same load is required to create that same extension. So on that planet, W is equals to mg, the weight or the load should be 10 Newton, and m, I don't know how much mass you have to put on the on that spring balance. The G value there is 10 by 5. The G value on the other planet will be 10 by 5. So if you find out the value of the m, it will be 5 kg. It means on that planet you will have to hang 5 kg mass, and then that extension will be created, which was created for 1 kg on the earth. And so each sample was each sample or each block was of 0.1 kg. So I need 5 kg. Each sample block was 0.1 kg. So how many blocks do I need? So divide 5 kg with the mass of the one block, 0.1 kg, and you will get 50. So I will require 50 blocks. So you see how many blocks I will require. That is, I will require 50 blocks. So the answer should be D. Question number 8. I think the option is D. Let's check. Question number 8. D is the option. Question number 8. D is the option. We should increase the size so you can see it more clearly. Okay, let's go to the next question. Question number 9 is showing on your screen. An electrically charged plastic ball is at rest. Which type of field are caused by the ball? An electrically charged plastic ball is at rest. You see, it's charged, it's plastic, so it has some certain mass, so it will have gravitational field around it, and it is in the gravitational field of the earth. Obviously it is charged, so it will have electric field also. It is at rest because it's not moving. If the charged body will move, it will have magnetic field around it. But if the charged body will not move, if the charged body is at rest, then there will be no magnetic field around it. So I think that electric and gravitational, it will have electric and gravitational field around it. So to me, it looks B looks the right answer. Question number 9, B looks the right answer. Let me check. Question number 9, you can see the B is the right option. Question number 9, B is the right option. Okay, question number 10 is showing on your screen. He says, which list contains only quantities that can be changed by a force? By applying force, you can change the shape of a body. By applying force, you can change the volume of a body. By applying force, you can change the velocity of a body. But by applying force, you cannot change the mass of the body. So which list contains only quantities that can be changed by a force, which can be changed by a force? So shape can be changed, velocity can be changed, volume can be changed. So to me, the first 3 options are wrong because they have enlisted mass. So mass cannot be changed by applying force. So D looks the right option. Shape, velocity, and volume, they can be changed by applying the force. So D looks the right option. Let's check the marking scheme. Question number 10. Oh, D is the right option. Okay. So next question on your screen. An extension load graph is plotted for a spring. Which point marks the limit of proportionality for this spring? So you see, this is extension and load graph. if the extension and load graph is a straight line, it means that the extension and load, they are directly proportional. If the extension and load graph becomes curved, it means that the extension and the load, they are no more directly proportional to each other. So the point after which the extension and the load graph becomes a curve, that point is known as the limit of proportionality. So if you look at carefully, so till point B, the extension load graph was a straight line. After the point B, it started curving upward. So B is the limit of proportionality. So question number 11, B is the right option. Let's check the. So B is the right option. Okay. Next question. Question number 12 is on your screen. The diagram shows a diver 20 meters below the surface of a lake. The total pressure at this depth is 3 expo 5 Pascal. An air bubble has a volume of 0.60 centimeter cube as it leaves the diver. When the air bubble is here, the volume is 0.60 centimeter cube and the pressure here is 3 expo 5 Pascal. It rises to the surface of the lake where the pressure is 1 expo 5 Pascal. The temperature of the air in the bubble remains constant. What is the volume of the air bubble at the surface of the lake? You see, and the temperature remains constant. So P1 V1 equals to P2 V2. I am applying this law because inside the bubble we will have air, we have gas. So it obeys this law. P1 V1 equals to P2 V2 when the temperature is kept constant. I have the value of the P1, that is 3 expo 5. I have the volume V1 value, that is 0.6 centimeter cube. And I have the value of the P2, that is 1 expo 5 Pascal. But I want to find out what is the volume. V2 is the question. Very simple question. Okay, so the next will be, I think I have done this. I think I have missed this question. I have not done it here. I have not taken its diagram, maybe. Okay, extension, then this crash. So I think I have not made this flip, but you can, let me show you. Let me share it with you. I have drawn that diagram. Let me check my paperwork. I have drawn this. Let me check, and if I have drawn that, I can share that diagram with you because that will be very helpful to you. Yeah, let me bring it here. Okay, let me take this snap and then I will share with you. We have to stop for a minute and let me take that diagram. Okay, so I have taken the photograph of that work. Unfortunately, I just let me bring it here. Let me take out that. I have that diagram with me. Okay, so let's download it. Okay, where are the snipping tools? I'm sorry, we have to do this during this lecture. And okay, so where are the snipping tools? So here we go. Okay, so okay, so let me increase the size. Oh, Jesus. Let me show you. This is question number. This is question number 12. Question number 12. Okay. So I hope that you are able to see this. Yeah, I am looking at my. Okay. So this question, you can see, this is how we will do the paperwork. P1 V1 equals to P2 V2. I know the P1 value, that is 3x per 5. The V1 value is 0.6 centimeter cube, and P2 value is 1x per 5, and V2 is the question. So you just do the mathematics, make the V2 alone, and you will get the answer 1.8 centimeter cube. 1.8 centimeter cube is the answer. 1.8 centimeter cube will be the answer. Okay. So okay. So let me copy the next question also, because then it will again, we will have to stop. From here, I need to copy this question number. This is a question number 15. And then I have question number. Copy. Let me just give me just 1 minute. I'm very sorry that I have to. Unfortunately, somehow I just missed it. But this thing is good for you. You'll be able to understand the question more easily. So let's make this easy peasy. Let me increase the size. This is question number 15. And then add a new slide. Here I will put the next question number 20. Okay. So I think we are good now. Okay. So where was I? Yeah, we were on this question. Very sorry for this. Okay. So 1.8 centimeter cube looks, C is the right option. Question number 12, C looks the right option. Oh yeah, C is the option. Now move to the next question. The next question is on your screen. He says a ball is dropped from a height as shown. Ignoring the effects of the air resistance, which statement about the total energy of the ball is correct? If there is no air resistance, you see the total energy of the ball will remain constant. Whether you stop it, whether you check it on the point A, whether you check it on the point 2, whether you check it on the point 3, the total energy will remain constant. That's the law of conservation of energy, that the total energy of the system do not change. The total energy of an isolated system remains constant. If there is no air resistance present, so there will be no loss of the energy. So at the position A, position 2, position 3, the total energy will be constant. It means at all these 3 points, the total energy will be same. So look at the options which are given. It is the same at all the points. That looks the right answer. It is greater than the point 1. That's wrong. It greater than the point 2. That's wrong. It is greatest at the point 3. That is also wrong. So A looks the right option. Question number 13, A is the right option. Question number 13, A is the right option, sir. Okay. Let's move to the next question. A student uses an average force of F to push a box a distance of D across a horizontal table. The mass of the box is M and the gravitational field strength is G. How is the work done by the student pushing the box calculated? We always calculate the work done by force multiply the distance moved in the direction of force. The work done is calculated by the formula force multiply the distance moved in the direction of the force. So I think W must be, work done must be equals to F multiplied D. A should be the right option. Question number 14, A is the right option. Next question, question number 15 is on your screen. A workman rolls a barrel of weight 2000 Newton up a plank of length 2 meter and onto a lorry. The back of the lorry is 0.80 meter above the horizontal surface of the road. What is the work done on the barrel against the gravity? You see, whenever you move something in the upward direction, the work done can be always calculated by the gain in the potential energy. If something moves upward, the final work done will be equals to the, one way of calculating the work done is equal to the gain in the gravitational potential energy by that barrel. So the work done will be equals to weight multiply height. The work done will be equals to weight multiply height, or mgh, where mg is weight. So the work done will be equals to weight multiply height. So let me take back to, I have done this calculation, and the work done will be equals to weight multiply height. So weight is 2000 and the height means the vertical height, that will be 0.8, so 1600 joules. So the answer will be 1600 joules. So to me, it looks B is the right option. 1600 joules, B looks the right answer. B looks the right answer. Okay, on your screen, we have question number 16. What is power? Power, the power is rate of work, the rate of transfer of energy. The power is basically work divided by time. The power is the energy divided by time. So it is work done per second. Force per second, that's wrong. The maximum force on an object exerts, that's wrong. The total energy of an object, that's wrong. Work done per second, work done divided by time. The rate of work done divided by time. So work done per second, that is the right definition. So power is work done per second. So D looks the right option. Question number 16, D is the right option. Okay, so the next question on your screen, 17, question 17. The diagram shows a glass tube filled with water and suspended above a bench. The water is free to circulate around the tube. At point P, there is a conventional current moving in the downward direction. So this water is basically going down. It means here it's going this way, then it's going upward, and it's circulating like this clockwise manner. Here the water, the conventional current is going downward. At which point is the tube heated to cause the convection currents? You see, wherever you will heat, from that point, the water will start moving upward. The water will go in the upward. So because the water here is coming downward, it means we have heated at the point A. If I will heat at the point A, if I will put a burner or Bunsen burner here or a candle here, I will heat from here. The water will become less dense. It will rise upward. Convection current will set in, and the water will circulate in this clockwise manner in these tubes. So I think the heating should be done at the point A. Question number 17, A is the option. And you can see A is the option. Okay. Which physical property cannot be used for the measurement of temperature? The length of a metal bar, that can be used. The mass of a plastic block, that cannot be used. Because with the change of the temperature, the mass do not change. We can use only that property which changes with the temperature. So mass, because the mass of an object do not change with the change in the temperature. So this cannot be used for measurement of a temperature. The pressure of gas, that can be used. The resistance of wire, that can also be used to measure the temperature. So B, he says, which cannot be used to measure the temperature. Important thing, which cannot be used to measure the temperature. So B is the right option, the mass of the plastic block, because the mass do not change with the change in the temperature. So B is the right option. 18B is the right option. Question number 19 is on your screen. A student performs an experiment to find out how much energy is needed to change the temperature of a steel nail by 1 degree centigrade. Which quantity is that student determining? You see, if you want to change the temperature of the body by 1 degree centigrade, the amount of heat required to change the temperature of a body by 1 degree centigrade, that is known as heat capacity. Don't confuse it with the specific heat capacity. The specific heat capacity is the amount of energy required to change the temperature through 1 degree centigrade of unit mass of that body. But if you only say that how much heat is required to change the temperature of a body through 1 degree centigrade, that is heat capacity. So I think this is the heat capacity of the nail. Which quantity is the student determining? This is the heat capacity of the nail. So A looks the right option. A is the right option. Yeah, marking scheme says A. Okay, so on your screen, we have this question number 20. A substance has a melting point of minus 17 degrees centigrade and a boiling point of 117 degrees centigrade. At which state does the substance exist? At minus 10 degrees centigrade and at 110 degrees centigrade. Okay. So minus 10 degrees and 110. I have drawn this on a... Okay. So on your screen, I hope you can see. Here I have drawn a line which is representing the temperature. So at minus 17 degrees centigrade I have shown here, and minus 17 means that let me make it the slideshow. Okay. Minus 17 means that is the melting point. So below this, the thing will be solid. Above this, the thing will be in the liquid form. 117 degrees centigrade, that's the boiling point. So above this temperature, the thing will convert into gas. And below this temperature, the thing will be in the liquid form. He asked us to determine the state of the thing at the temperature of minus 10. So I marked minus 10. The minus 10 will be here somewhere. And 110 degrees centigrade. You see very easily, both these temperatures, the thing will be a liquid, because 110 degree is below the boiling point and minus 10 degrees centigrade is above the melting point. So at minus 10 degrees centigrade, the thing will be liquid. At 110 degrees centigrade, it will be liquid. So in both the cases, it is liquid. So at both the things, at both the temperatures, minus 10 degrees centigrade, the substance will be a liquid. At 110 degrees centigrade, the substance will be a liquid. To me, C looks the right option. Question number 20. Let's check the marking scheme. C is the right option. You see, very important. Whenever you are solving this kind of question, always draw a number line like I have drawn, and then it will be very easy to decide. Question number 21 is on the screen. Which description of a liquid is correct? Liquid has a fixed volume. Liquid do not have fixed shape. So look at the options. The liquid has no fixed shape, but its volume is fixed. So to me, C looks the right option. Question number 21, C looks the best option. Question number 21, C is the right option, sir. Okay, so here we go. The next question is 22. A mass of gas is trapped inside a cylinder by a moving piston. As the piston moves in, the volume of the gas decreases, but the temperature stays the same. The temperature is not changing. P1 V1 equals to P2 V2 can be applicable. What happens to the gas pressure and why? Because your piston is moving in, so the volume of the gas has decreased, so the pressure will increase. When the piston will move in, the gas pressure will increase. And why? There are many reasons. One of them is that the molecules, the collision frequency of the molecule with the wall will increase. The collision frequency of the molecules with the walls will increase. So the molecules collide more frequently with the piston. Decrease, for example, look at the options. Decrease is not possible. Increase, unchanged is also not possible. Increase, the molecules collide more frequently with the piston. So C looks the right option, sir. Question number 22, C is the right option. Okay, next question. A plane mirror on a vertical wall forms an image of an object placed in front of it. Which characteristic describe the image? The image which is formed in the plane mirror, it is virtual. The image is upright, or you say erect. The size of the image is equal to the size of the object. The distance of the image from the plane mirror is equal to the distance of the object from the plane mirror. The image have what we say, it is laterally inverted. Laterally inverted means the right of the object appears to be left of the object, and left of the image. The left of the object appears to be right of the image. So the image should be virtual. The image should be upright. It should have the same size as the object. So to me, first two are directly wrong. They are straightforward wrong. Because the image is not real. The image is virtual. So C or D couldn't be the option. The image is virtual, the image is upright, and it has the same size as that of the object. So D is the right option, sir. Question number 23, D is the right option. Oh, question number 23, D is the right option according to the marking scheme. Okay, next question on your screen. Question number 24 is showing on your screen. Which statement about light passing from air to glass is correct? The frequency of the light waves decreases. No, the frequency, when in our course, in O-levels course, when the waves will enter, light even enter from one medium to another, its frequency do not change. So the frequency of the light wave decreases. That's wrong. The speed of the light wave decreases. Yes, that is possible. The light passing from air to glass. In air, the light has more speed. In the glass, its speed will decrease. That can be the option. The wavelength of the light wave increases. The light wavelength will only increase if the speed will increase. The wavelength of the light wave remains unchanged. That's not possible. If there will be a change in the speed, the wavelength will also change. If the speed will become more, the wavelength will become longer. If the speed will decrease, the wavelength will become smaller, and the frequency do not change. So the speed of the light wave decreases. That's the best option. Whenever the light enters from air into glass, the speed of the light decreases in the glass as compared to its speed in the air. So B looks the right option. B looks the right option. Question number 24. Let me check. Question number 24. Yes, sir. B is the right option. Okay, so we are moving to the next question. That's question number 25. 25th question. Applications use different components of the electromagnetic spectrum, which shows correct application of X-rays, ultraviolet light, and microwaves. X-rays. X-rays can kill cancerous cells. They can do the medical imaging. And ultraviolet light, UV light is used in the fluorescent tube. That's right. Sterilizing surgical instrument. That is also right. Television controller, no. Television controller, no. So the last two options, C and D, they are gone because the UV light is not used in the television controllers. So C and D cannot be the options. A and B, they can be. But B is the right option because X-rays are not used in the mobile phone. And the microwaves, intruder alarm, no, microwaves are not used in the intruder alarms. Microwaves are used in the satellite television. Yes, that's true. The microwaves are used in the sunbed, sorry. So from A and B, B looks the right option. X-rays are used for killing the cancerous cells. Ultraviolet light is used for sterilizing the surgical instruments. And the microwaves are used for the satellite television. Question number 25, B looks the right option. Question number 25, B is the right option. Question number 25, B is the right option. Okay, so next question on your screen. Where does sound travel the fastest? You remember, the sound travel fastest in the solids, then in liquids, and then in gases. The sound travels fastest in the solids. It's a fact. D is the right option. Question number 26, D is the right option. Yes, according to the marking scheme, D is the right option. I hope you have understood this. Okay, so we are moving to the next question. Let me reduce the size. Further decrease. Okay. A scientific research boat uses pulses of ultrasound to detect fish underneath it. A pulse of ultrasound is bounced from a group of fish 6,000 meters directly below the boat. The next pulse is sent out 2 seconds after the echo from the previous pulse has been received. The speed of ultrasound in water is 1500 meters per second. What is the vertical interval between the two pulses? Okay. So the fish is 6,000 meters below. The speed of the ultrasound is 1500 meters per second. Let me show you. Okay. So here we go. So hopefully you can see this. So here we have the ship. It will send the ultrasound down. From the fish, the ultrasound will be reflected and it will come back. Because the fish is 6,000 meters below the fish, so the ultrasound has to travel how much distance? The ultrasound has to go down 6,000 meters, and then again it has to travel 6,000 meters back to the ship. So the total distance traveled by the ultrasound is 6,000 by going down and 6,000 coming back. So the total distance traveled by the ultrasound is 12,000 meters. The speed of the ultrasound is given to us 1500 meters per second. So the time taken for the ultrasound to go and get reflected back from the ship, from the fish and come back to the ship is distance divided by speed, 12,000 divided by 1500, it will be 8 seconds. So the time between the one pulse and the second pulse, they sent the first pulse, and when they got the echo, after getting the echo, they waited for 2 seconds and then they sent the next pulse. So echo took 8 seconds to come back, and then further 2 seconds they waited. So the total time taken between the first pulse and the second pulse will be 8 plus 2, 10 seconds. I hope you have understood this story. They sent a pulse and then they got back the echo. After getting the echo came after 8 seconds. They waited for further 2 seconds and then they sent the second pulse. So 8 seconds for the echo and the next 2 seconds for they waited after the echo. So the total time between first pulse they sent and the second pulse they sent, that will be 8 plus 2, 10 seconds. I hope you have understood this story. And 10 seconds. So D looks the option. Question number 27. Question number 27, D looks the right option, and it is the right option, sir. I hope you have understood this question. Okay, so here we go. Which row correctly describes ultrasound? Ultrasounds are sound waves, so they are longitudinal waves. We call them compressional waves also. Ultrasounds are longitudinal waves. So A and B can be the option, C and D is totally wrong. And the ultrasound frequency is more than the audible frequency range of human. The upper limit of the audible frequency range is 20,000 hertz, 20k hertz, 20 kilohertz. So the frequency of the ultrasound should be more than 20,000 hertz, 20 kilohertz. So B looks the right option. Question number 28, B looks the right option. Okay. Question number 29. What is stored in a battery and what is its unit? In the battery, we store, the current is not stored. It basically the battery has stored chemical potential energy. So in the battery, we basically have chemical potential energy. So basically the potential energy is stored in it. Chemical potential energy. And the unit of the energy is joules. So the C looks the right option to me, but let me check. Question number 29. C is the right option, sir. This question can confuse many students because normally the students will think that the battery has current stored in it. It has chemical potential energy stored in it. Okay, so we have question number, I think, this is question number 30. Okay, here we go. A car battery delivers 150 kilocoulomb to a circuit, amount of charge he has given you, to a circuit before it needs recharging. Two headlamps connected in parallel to the battery are switched on. There is a current of 4 ampere in each lamp. How much time passes before the battery needs recharging? I have done this on a paper. Let me show you my working. Okay, so you see, I have shown here 2 lamps which are parallel to each other, and in each lamp there is a current of 4 ampere. So because the lamps are connected in parallel to each other, and in each lamp the amount of current is 4 ampere, so the current coming from the battery is 8 ampere. So I know that I is equals to Q by T. The current coming from the battery is 8 ampere, and the charge we are talking about is 150,000 coulomb. 150. So divided with that, so 8 equals to 150,000 divided by T. So take the T to the other side, 8 will come downstairs. So I got 18750 second. But the answers which are given in the options, they are in hours. So how I will convert seconds into hours? I will divide it with 3600. Why? Why I will divide with 3600? Because, in 1 hour, there are 3600 seconds. So divide 18750 seconds with 3600 and it will be converted into hours. So do this calculation on your calculator and the answer is 5.2 hour. 5.2 hour. 5.2 hour. So let me check the answer. Do we have this answer? Yeah. So B is the right option. 5.2 hours. 5 point, okay, question number 30. B is the right option, sir. Okay, here we have next question. He says 3 identical lamps and 3 ammeters are connected as shown. The readings on the lamps are identical. Remember, the lamps are identical. The readings on the ammeters are I1, I2, and I3. So look at here carefully. The I1 current is coming out of the battery. And here the current splits. So the current is divided. I2 current passes through this branch, and I3 current passes through this branch. In this branch, there is only one lamp. And in this branch, we have 2 lamps, and all these lamps are identical. So this branch has lower resistance because it has only one lamp. Here, in this branch, I have 2 lamps. So the resistance of this branch is more, rather it's double as compared to the resistance of this branch. And you know, the current likes that branch which has less resistance. So the upper branch, where there's only one lamp, the amount of current will be larger because the resistance is smaller. In this lower branch, where you have 2 lamps, here the resistance will be larger and the amount of current will be smaller as compared to the current in the I2. And the I1 will be equals to the sum of these 2 currents, I2 plus I3. So it means that the I1 is the largest in amount, then the I2, and then the I3. So the readings on the ammeters are I1, I2, and I3. How are the readings related? So I1 will be the greatest, then the I2, and I2 will be greater than the I3. I1 is greatest of all. So it's a little tricky question, and I hope that you can understand this. I hope that you have understood this. Okay, a very tricky question again. A thermistor and a light dependent resistor, LDR, are connected in series. A potential difference of 6 volt is applied across them as shown. So the voltage of the battery is 6 volt. So here we have a thermistor, we have a LDR, and the 6 volt battery is connected with them. They are connected in series with each other. So you can take it as a potential divider. So the potential divider thing should come in your mind. The thermistor has a resistance of 6,000 ohm in a cold room and 1,000 ohm in a warm room. So there are 2 resistances of the resistance of the thermistor given. If the temperature is the room is cold, its resistance will be 6,000. If the room is warm, its resistance will be 1,000. The LDR has a resistance of 2,000 ohm in dim light, and 500 ohm in bright light. So 2 resistances of the same LDR is given. If there will be light, the resistance will be 500 ohm. If there will be darkness, the resistance dim light, it will be 2,000 ohm. When the potential difference across the LDR equals to 2 volts, so here they have connected a voltmeter and they are measuring what is the voltage drop across the LDR. So that is 2 volt. From the battery, 6 volts are coming, the LDR is taking 2 volts. It means that the thermistor will have to take 4 volt. LDR will take 2 volt, thermistor will obviously take 4 volt. It means the resistance of the thermistor should be double of the LDR. Because it takes 4 volt and the LDR will taking only 2 volt. So the resistance of the thermistor should be double of the resistance of the LDR. So in the given numbers, I have to look resistance of the LDR and I will pair it with the resistance of thermistor, which is double of this. So if I take 500 ohm, LDR resistance 500, its double will be 1000. It is given for thermistor. So if I take this 500, it should be bright light, and if I take from here, I will have to take 1000. It should be warm room. So he say when is the potential difference across the LDR equals to 2 volt? It should be a warm room and bright light. The resistance of the LDR, whatever is that resistance, the thermistor resistance should be double of that. Why? Why I know this? Because he said the LDR is taking 2 volts. From the battery, 6 volts are coming. If the LDR is taking 2 volts, the thermistor will take 4 volts. The more the voltage it is taking, the higher its resistance is. If it is the LDR is taking 2 volts, thermistor is taking 4 volt, it means the resistance of the thermistor should be double to the resistance of the LDR. There are two resistances of the LDR given, 500 and 2000. 2000 double will be 4000. In the thermistor, 4000 is not given. 500, if you take 500 ohm, its double is given here. So that can work. I have done this on a paper also. Let me show you. But here I have done with a different method. You see, I have used the approach of potential divider. So I use that formula. Okay. So he said that the V out at the LDR is 2. So if the V out is 2 volt, the voltage from the battery is 6 volt, it's the potential divider thing. So you know that the V out formula for the potential divider is R2 divided by R1 plus R2 into the voltage of the battery. So the V out here is 2, R2, whatever is the resistance R2 is this, R1 is this, R2 by R1 plus R2 into 6, voltage of the battery is 6. This R1 plus R2 means the total resistance. So if I take this 6 to the other side, it will become 2 by 6, which will 1 by 3. So the R2 divided by the total resistance is 1 by 3. It means that whatever is the value of the R2, the total resistance of the thing should become 3 times more. It's a little tricky. Mathematically, you have to think. So from the given option, if I take 500 LDR resistance and 1000 thermistor, then the total resistance will become 1500. So 500 divided by 1500 will give you 1 by 3. So this is one approach. By this approach, you can find out the R2 and R1 value, the resistance of the LDR and the resistance of the thermistor and their conditions. This looks a little more difficult, I think. But the other way or the approach I just told you, that if this take 2 volt, if the LDR taking is 2 volt, from the battery 6 volts are coming, then the thermistor will be taking the 4 volt. So the thermistor is taking double the voltage as compared to the LDR. The potential difference across the thermistor is double to that of the LDR. So it means its resistance is also double. So if the LDR resistance is 500, its resistance will be 1000. So from there, I came to know, okay, what are the conditions. For 500 in the LDR, it should be bright light, and 1000 for the thermistor, it should be warm room. So it should be bright and warm room. So C looks the option. For 32, C looks the right option, sir. It's a very, question number 32, C is the right option. I think we have 31. Yeah, 31. In 31, D was our option. 31D was the option. Okay. It is a tricky question. A 240 volt main circuit contains 860 watt lamps in parallel. At the time when the lamps are switched on, the filaments are cold and the current is 4 times as large as the final steady current in the circuit. What is the initial current supplied by the main? So here you have 60-watt bulbs and 240-volt main supply. The voltage you are providing is okay. So let me show you. I have tried to solve it. I hope it's right. So let me show you. This is how I have tried to do this. So we have 8 bulbs, 8 lamps, I think, and they are connected parallel to each other. He said parallel to each other. So each lamp has a power of 60 watts, 60 watts, 64. So the total power will become 8 multiplied 60, that's 480 watt. So the total power of 8 lamps will be 480 watt. And you know the power is equal to IV. So the power is 480 and the I is the question and 240. So 240, 480 divided by 240 and the I will be 2 amp. 2 amp. So suppose I'm not sure about this question. Do we have this option? C. Question number 33, C looks the right option. Question number 33, D is the right option. So let me reconsider this thing. 240-volt main circuit contains 8 60-watt lamps in parallel. At the time when the lamps are switched on, the filaments are cold and the current is 4 times as large as the final steady current in the circuit. What is the initial current supply? Oh, yes. Yes. When you started the lamps, the current is 4 times. I just calculated. Let me show you. 2 amps. This is right. But this is that current when the lamps has started working. When the lamps have started working, they have become hot and they have started working and they have become hot. So obviously this is the steady current which has started flowing through them. That's 2 amperes. But he says when I switch them on, that moment when it switched them on, the lamps were cold and the current which flowed through the circuit, that was 4 times to this current. 4 times to this current which we have got from the calculation. So you multiply 2 with 4, it will become 8. 8. So D is the option. Question number 33, D is the right option. Question number 33, D is the right option. Sir, understand, try to understand this thing. In this question, I did the calculation, simple calculation. There are 8. Let me show you again. There are 8 lamps and those lamps are, here we have the 8 lamps. Each lamp is of 60 watt and they are connected parallel to each other and they are connected with a battery which is of 240 volt. So in the parallel, each has 60 watt power. So the total power of the whole circuit will become 8 multiplied 60, 480 watt. So when this thing will be working, the current flowing through them will be, the current coming from the battery will be P is equals to IV 480 divided by 240 and 2 ampere. But this is the current which will be flowing through them when they will be working. But he said when I switched on the circuit, the current which flowed through the circuit was 4 times more than the current which actually when they will be working. At that moment, whatever will be the current at the start was 4 times more than this. Let me show you these sentences. Let me read this sentence again. At the time when the lamps are switched on, the filaments are cold and the current is 4 times as large as the final steady current in the circuit. So the current which we just calculated on that diagram, which I just showed you, that is the steady current. But the current at the start, he says, that is 8 times more than this steady current. So 4 multiplied to 8, D is the right option. Question number 33, D is the right option. So I hope you have understood. Very tricky question. It was a very, very tricky question. What is used with a magnet to create and induce electromotive force in a simple AC generator? You see, in an AC generator, we have magnet and we have a coil, and the magnet and the coil relatively they relative to each other move. So they move relatively to each other. So this way the current is induced. He says, what is used in electromagnet? Sorry, what is used with a magnet to create and induce electromotive force (EMF) in a simple AC generator? A battery? No. A coil of wire? Yes. A voltmeter? No. A relay? No. A coil. We have a coil, we have a magnet. If they move relative to each other, EMF will be induced in that coil. This is called uh, magnetic induction. So B is the choice. Question number 32, B is the right option. Okay. What changes kinetic movement energy into electric energy? A car battery? No. An electric fire? No. An electric motor? No. A wind turbine? Yes. Wind turbine converts the kinetic energy into electric energy. A wind turbine. Question number 35. D is the right option. Okay. Question number 36. A transformer has 4,800 turns on its primary coil and 480 turns on its secondary coil. The primary coil is connected to a 240 volt AC supply. The secondary coil is connected to a lamp. How does the output current in the lamp compare with the input current? The current which will be produced, that will be the alternating current. The current which is induced in the secondary coil, that will be alternating current. Its frequency will be the same frequency which is of that of the current which you provided in the primary coil. The frequency of the current which is in the primary and the frequency of the current which is produced in or induced in the secondary coil, both will have the same frequency. High frequency AC, no. Lower frequency AC, no. Current in one direction only, no, because alternating current is produced. It is not flowing in one direction. The same frequency AC, yes. So D is the right option. Okay. There we go. Okay. A cathode ray oscilloscope with the Y gain set at 2 volt per division is connected to a generator. So here we have a CRO, and the screen of the CRO is like a graph, and the y-axis of this graph represents the voltage, and a scale is given. Each square or each division on the y-axis is representing 2 volt. So if you look at, this is the mean position, and how much it went up? It went 1.5 squares from the mean position. It goes up how much? 1.5 squares up, or 1.5 divisions down. This is the mean position. So 1.5 multiplied 2. 1.5 multiplied 2 will give you 3. So the amplitude of this wave is 3. So which road describes the signal from the generator and its amplitude? This is from the mean position, it's going up, it's going down, so it's alternating current, and the amplitude is 3. So A looks the right option. A is the right option. Question number 37. Question number 37. To me, A looks the right option. Yes, A is the right option. Okay. A potential divider uses a power supply of 12 volt. The resistor X and Y initially have equal resistance. At the start, they both have the same resistance. the resistance of the X is halved. What is the change in the output voltage? Okay, so what will be the change here? Let me show you. I have done this. And this is how. First, V out from the R2 is a potential divider. Remember this equation. V out is equals to R. Oh, by mistake, I wrote here R1. It is R2 basically. This is R2 divided by R1 plus R2 into the VB. R1, sorry, R2 is X, same. R2 and R1 both were equal to each other. So X plus X, so it will be X by 2X. So X and X cancelled. So 6 volt. The V out, when the R1 and R2, they both are equal to each other, then the V out will be 6 volts. Here by mistake, I have written R1. This is R2. Okay. So if you are working, kindly make it R2. Okay. This is R2 divided by R1 plus R2 VB, because we have taken the V out from the R2. Then he says, I made the R1 half. Whatever its value was, I made it half. Okay, so I will write this formula again. V out is equal to R2 divided by R1 plus R2. The value, I suppose, is X of the R2. But R1 has now become half. Sorry, R1 has become half. So it will become X by 2 plus X. So if I add X by 2 plus X, so it will be 3 by 2X. So when X and X gone, so it will be 2 by 3 multiplied 12. So it will give you 8. A little mathematics. I hope you understand this mathematics. So now this time the V out on the R2 will be 8 volt. Previously it was 6 volt. So what is the difference between them? Now it is 8. Previously it was 6. The difference is 2 volt. C looks the right option. 2 volts. C looks the right option. Let me explain you again. But first of all, check the answer. Okay, 30 C. C is the right option. Okay. This is a potential divider. This is R1. This is R2. So from R2, we have taken the V out. The voltage from the battery is 12 volts. So the formula, remember this formula, V out is R2 divided by R1 plus R2 into the voltage of the battery. So this is how it works. You should remember this formula. Never forget this. Okay. So this is question number 39 on your screen. What is the definition of the half-life of a radioactive element? Don't forget this definition. Half of the time it takes for one atom to decay? No. Half of the time taken for all the atoms in a sample to decay? No. The time taken for half of the atoms in a sample to decay, that is the right definition. The time taken for half of the atoms in a sample to decay, that is the right definition. The time taken for the nucleon number, mass number to have? No. C is the right option. The definition, the C is the right definition. The time taken for half of the atoms in a sample to decay. C is the right option for question number 39. Okay, now we have question number 40 on your screen. Which row shows the atomic structure of a neutral atom with a nucleon number of 9? Which row shows the atomic structure of a neutral atom with a nucleon number of 9? Okay, so look at the columns carefully. Number of neutrons in the first column, number of protons in the second column, number of electrons. For an atom to be neutral, the number of protons and electrons should be equal. These two numbers, they should be equal. Okay. And for a nucleon number to be 9, the number of neutrons plus protons, that should be 9. I've done this on a paper. Let me show you here on your screen. So the nucleon number is neutron plus the proton. So the first, second, third, their nucleon number is 9. So 10 is out and the last one is out. It cannot be the option. For the neutral atom to be the neutral, the number of proton and electrons should be same. This one, this second, the B looks the right option. B should be the right option. Question number 40. B is the right option. So by this question, this was question number 40. We have reached the end of this paper. So, my dear students, today we were working on October-November 2020 1-2 paper. It was an MCQ paper, and I have tried my best to explain you the concepts. I have tried my best so that you don't have to worry. And by sitting at your home, by looking at these YouTube videos, if you play them and you have a hard copy of that paper with you, I hope you will be able to understand. And if you are looking this video, I will request you today that if you are looking this video and this video is helpful to you, kindly subscribe my channel also. My name is Ferhan Mazher. So thank you very much, everybody. Have a good day and God bless you all.